My name is Jody Lee, and I will be moderating this webinar, Effectively Using Imagery for Precision Agriculture. I'm excited to be joined by Austin Coates, Technical Lead for Precision Agriculture at Harris Geospatial Solutions. Austin has a background in vegetation mapping and monitoring. He previously worked on projects that range from monitoring and mapping palm oil plantations for the EPA, helping to correlate forest biomass and ground topography for NASA JPL, and developing new techniques for species-specific drought monitoring with regards to the Hespera campaign. While at Harris, Austin wrote the initial implementations of most of the ENVI Crop Science tools that will be shown in this webinar. Just a couple of housekeeping items before we get started. I've muted the phone lines for all attendees, so if you have any questions at any point during the webinar, enter them into the questions chat box. We will answer as many as we can at the end of the presentation, and if we don't get to your question, then someone will follow up with you. We are recording this webinar and will email you the link in the next 24 hours. It will also be available on our website at www.harrisgeospatial.com, and we encourage you to share with your colleagues. So without further ado, I'm going to turn things over to Austin.
Thanks, Jody. Hi, everyone. My name's Austin Coates, like Jody said, and I'm the technical lead for the Precision Agriculture team here at Harris Geospatial. So today I'll talk a little bit about what Harris is, and then I'll kind of go over some imagery information, a little bit about Ndvi and how to generate an Ndvi or what it means. I will give a demo of crop counting, crop metrics, outputting the results to a shapefile, and then also doing some spatial statistics on those results. And then I will talk about how all of these offerings can be deployed directly into the cloud. I'll give a quick summary on what we had just covered, and then I'll talk about a white paper that we have coming out, as well as open it up to questions and answers. All right. Without further ado, so the Harris Corporation is a 17,000 employee corporation. We're worldwide, and 7,700 of us are scientists and engineers. There are 4 different business sectors within Harris. The one that my group falls in is the space and intelligence sector, and within that it is Harris Geospatial. Our main image processing offering is ENVI, and ENVI is an image analysis software. It's used by GIS professionals, scientists, and imagery analysts to extract meaningful information from imagery to make better decisions. ENVI can be deployed and accessed from the desktop, in the cloud, and on mobile devices, and can be customized through an API to meet specific project requirements. ENVI is it's a whole suite of different image analysis algorithms, and it's a great product. You can do a whole host of different things. Today I'll show a little bit of what you can do with it, as well as how the crop science module fits into that. So we have a couple of other products as well. So ENVI Starscape, this looks at synthetic aperture radar, and that's a great modality that can be used for looking through clouds. So optical is what we usually see when we look at an image. So it's true color, red, green, blue, what you normally expect. Whereas synthetic aperture radar is actually a radar pulse that travels through the atmosphere and then interacts with the ground. So a lot of research has been done recently using SAR and rice fields and determining different characteristics about those rice fields. So perhaps that's a future topic, but yeah, you could use Starscape to do that type of research. ENVI Crop Science, that's the one that I'll cover today. This is our precision agricultural offering. And I'll get a little bit more into that. ENVI One Button, so we've partnered with Icarus One Button to offer sort of an end-to-end solution. This is specifically exciting for agriculture because One Button now offers from initial collection all the way through mosaicing of the MicaSense Red Edge camera. So you now can take raw images, put it in, get a mosaicked image, and then feed that directly into the Crop Science module or ENVI and do some processing with it. You don't have to go outside of those 2 software packages, you're just ready to go. And then we also have the Geospatial Marketplace. This is where you can buy imagery, you can identify regions where you want to look and see what imagery is available. It's it's all in one place. It has a very easy to use front end. So you can go in, look at all your different imagery providers and select what image is right for your application. All right, now to get into a little bit of the science behind the imagery and the image processing workflow. So to start with, this is a Ndvi image. Many of you probably have seen an image that looks very similar to this. Green meaning healthy, red meaning not so healthy. So how is this image derived? What is this image telling us, and kind of how to use it? So the image, the underlying data, it comes off of usually one of these three different sensors. So it's either going to come from a UAV or a drone or a UAS. Those are all kind of synonyms for the same thing. You can also have a satellite or an airborne platform. If you're using ENVI, ENVI is a data agnostic platform. We can take in anything that you provide to us and we can work with that data. So once the data has come off of the sensor and then gone into ENVI, what can you do with it then? You can then begin to analyze the different intensities of light that are being collected by this sensor. So when the light travels from the sun, it passes through the atmosphere, it hits whatever your target is, and then it reflects back to the sensor. So in our case, so if we were to look at healthy vegetation, the light would come through the atmosphere, it would hit a plant, a healthy plant, and it could either be absorbed, transmitted, or reflected. And the reflected portion is the portion that a passive sensor is most interested in. So if we had just a 4-band sensor, so something that looked at blue, green, red, and near infrared, a healthy plant would reflect light that looked like this. So it would be a little bit less in the blue, red, and then a little bit more in the green. That's why plants appear green to us, is because it's using the blue and red light and reflecting a little bit more of the green light. And then it reflects a whole bunch of near infrared light. If we were to look at the differences between the red and near infrared spectra, it tells us a little bit about the health of the plant. So based off of the chlorophyll in the plant, the water content, kind of the structure, it all tells us a little information about how healthy that plant is. So for this very healthy leaf right here, you have a little bit of red light coming back and a lot of near infrared light coming back. If you combine these two together in a mathematical equation, so near infrared minus red over near infrared plus red, that's just the equation for Normalized Difference Vegetation Index, or Ndvi. So that's just a statistic saying how much near infrared light as compared to red light is coming back. If you were to look at a senescent or dead leaf, you would see that just a little bit of near infrared light and more red light is coming back. So you have a much shallower slope between these two, and that gives you a different value completely. So in this instance, the green areas would be a lot of near infrared light coming back and a little bit of red light. The red areas would probably be a lot of red and a lot of near infrared coming back. So that's kind of an explanation of how you would derive a broadband greenness vegetation index. All the 27 different indices here are all pretty much derived from that phenomena of more near infrared light coming back and less red, blue, and green light coming back with respect to healthy green vegetation. We have these 27 indices right here can be used on broadband sensors. So these are the sensors that most people are familiar with. So just like I said before, MicaSense or say Landsat or something kind of that nature. So you have a couple of distinct bands. Whereas if you were to get into hyperspectral imaging, then you can get into very, very specific wavelengths of light. So it's not only red, it is now a very, very narrow portion of that red spectra. And if you can pull out that information, then we have even more vegetation indices. We have a total of 51 total vegetation indices that you can take advantage of. These can look at nitrogen and water content and the health of the plant. You have a lot of options. All right, the demos that I just showed were kind of wall-to-wall vegetation. So if you had a center pivot field and you were to look at the vegetation from one side to the other side, you really have no gaps in there. So if you run an Ndvi, the color range that you're going to look at is just going to be spread across the vegetation. Whereas in this case, say you had an orchard that you were managing, it's a little bit harder to tell what's going on because you have soil and you have trees. The soil is going to show up as a very low value, the trees are going to show up as a very high value, and because of that, it's hard to display that on the screen. The dynamic range is very big, so you don't see a whole lot of variability within just the healthy trees. So how can we get around this problem? We can use something like our ENVI Crop Sciences module to identify and isolate those individual trees and then run some statistics on each individual plant instead of the whole scene. So I can give a quick demo of this. So this is ENVI. This is our image processing suite. So we can go in there and kind of mess around. So I've already loaded in one image, the one I was just showing, and you can see these are the available bands that we have access to. We have a blue, a green, a red, and a near infrared band. If you were to look at the spectra, we could see that for this healthy tree, like we were saying, the green portion reflects a little bit more, the blue a little bit less, the red even less, and the near infrared a lot. Whereas if we were to look at the soil is just kind of that rounded slope that we had seen before where you're not getting that nice separation between near infrared and red. So to do crop counting, what we want to do originally is we want to isolate the trees. We can do that in two different ways. We could run a spectral index because we have access to this near infrared band. We can take advantage of that. So we could run something like Ndvi. So I'm currently selecting my available spectral indices. This is going to go through, look at the bands that I have available to me, and return a list saying you can run all of these on that specific image. So for this one, once again, we'll run Ndvi and take a look at it. We'll save that off. This is our result. It does a great job. You can see that our trees are nice and bright and our background is nice and dark. That's exactly what you want for the crop counting portion of this. Or if you had only a red, green, blue image, so say you're just using a true color camera, you had no access to anything outside of the visible spectra, you could use our Enhance Crops tool to take in, let's pretend this is red, blue, green. We would just select one of the bands. So in this case, we could just select the green band. And then you could do something like inverting the green band. So if we have just the green band, that's just going to be a grayscale image. And then if we were to invert it, the trees currently will show up dark and the soil will be a little bit brighter. Whereas when we invert it, it will change that so the trees will be bright, so it'll be dark. So let's preview it, take a look at how we do. There we go. It's a totally viable option for crop counting. Looks great, trees are nice and bright, background is dark. And we could use that if we wanted to. These two parameters are in here. I'll show them a little bit later, but the minimum data value and maximum data value, these are just thresholds. So say I wanted to cut out the soil in between, I could put a minimum threshold for that soil value and cut it out. In this demo, it's not important. We can run it without it, but later on I'll show you how we can use that. All right, if we remove this preview, and now let's do crop counting on our Ndvi image. So if we pass in that image that we just created, we select a minimum crop diameter and a maximum crop diameter. For this orchard, I know the trees range from about 1 meter to 5 meters. And then in between that, I'll look at 5 different increments. The Gaussian smooth, this just smooths out your image a little bit. So say your canopy was kind of speckly, or you had a really, really high resolution image where your canopy showed a lot of variation in its texture, and you just needed to smooth that out, and you just want nice round blobs for your plants, and you don't really care about that high frequency texture in there. You could turn this up. Right now, I'll just leave it at the default of 0.5, and we'll go from there. Include edges. So this will run all the way up to the edge and include it, whereas if you exclude that, then based on the algorithm, it just kind of clips off the edges a little bit. Allowable overlap. So this just says if I were to have 2 plants that were overlapping each other, what is my allowable amount? So in this one, it doesn't really matter because my trees are nicely separated. So I could either go with 0 or I could even go with 100 if I wanted to. It doesn't really matter so much. But say you had a strawberry field or something where you have big round plants, but they're planted very close together, and there is a portion of them that are overlapping each other. Maybe it's 10% or 20% of the plants are overlapping each other. You could set that value so that you could get an accurate count. And then intensity threshold, I'll preview this for now so we can see what's going on, and then I'll explain kind of what the intensity threshold does. All right, so this is what we're looking at currently. So it's doing a great job. We're counting most of our plants. We can see everything. However, we have a little bit of extra along this edge over here. It might be easier if I turn this on so we can see that. So if we look, we have a little extra. However, all of our plants are looking like they're very bright. They have very high values, and these have very low values. So if we were to turn on our intensity threshold, we could select something like 0.8, which says I'm going to keep the top 20% of my values in this image, so my really, really bright stuff, and I'm going to clip off anything below that. So let's take a look and see how it does. That looks great to me. Looks like it clipped off all the dark stuff along the edges, and it kept all of our nice bright plants. I'd say that's a pretty good result, so let's go with that. This portion here, this is our output crops file. So this is just a JSON file that we can pass around to the other algorithms so that we can use the locations of these plants in further processing. So if I save this off, and I'll save this off as well. This is just a raster representation of what we just created. So it's going to look just like what we have on the screen here, except it's just going to be a raster that we can use and later display. So let me, oops. We'll name it the same thing. All right, and then this last portion, this fill raster crops, yes or no. That just means do you want to fill in the circles or not fill in the circles for visualization purposes. Right now, I'm not going to fill them in. I kind of like how it looks where they're open. So let's create these two files. We'll look at our results. All right, results look very similar to what we had on the screen. So now what we can do is we can go into each one of these circles and let's pull out some metrics about it. Let's look a little bit more into the statistics and kind of the health of these plants. So I can do it in two different ways. I can either just use my Ndvi image that I've already created. So I already have some image that I want to pull the data out of, and that would be with crop metrics. Or I can take in a multi-band raster. So for example, that red, green, blue near infrared image from the beginning. And I can have it tell me which vegetation indices I can run on it. I can select one, and then we can go from there. So that's what I'll do for this one. So we'll go into, I'll use my initial image. I'll select some index. So say I want to look at green normalized difference vegetation index. It tells me a little something different about my crops. I'll put in that crops file that I just created. I'll calculate the mean value over each one of the crowns. I can create a classification raster or just the regular values put out to the screen. The classification just means it goes through, looks at all the range of values in there, and then bins them up into 7 different classes. And then this output crops raster, this is the resulting raster file. So this is what it will be saved out to. So if I do crops, we'll call it class. And then this output crops file, this just saves all of our crop metrics into that JSON file again. So if we do crops, JSON, and then we do, let's call it mean GNDVI. And then if we run this, all right, so we get a result like this. This is showing us the GNDVI, the mean GNDVI for each one of these crowns. So as we remember before, our NDVI image, we were having a hard time seeing what was going on with each one of these plants, whereas this tool zooms into each plant individually. It gives us a nice count for all the plants. So we can see here, we've counted 1,045 plants. And then we can also begin to see, well, maybe there's a little bit of structure in here. Maybe there's something going on here. Maybe there's something going on up here. It's hard to tell exactly what's happening in here, but you can kind of see what's happening. If you wanted to really drill into it and look at the structure, we could run this same task again. So if we do the same thing again, however, this time we can do We can run GNDVI again. We'll input our crops from before. We use our mean again, and this time we'll turn the classification off. We can output our raster again. So we'll call it crops mean dot. Just making sure I didn't call it the same thing last time. All right, and this time it would generate the exact same file as before, so we don't really need to put that in this time. So we'll run it again. All right, and so this is just the mean value for each one of those crops. What we can do with this now is we can run the hotspot tool and get some spatial statistics. I'll go back to my presentation for 1 second so I can explain kind of how the hotspot tool is going to work, and then we can run it and we can check it out. All right, so this is kind of what we were looking at before. You can see once again, you might have some structure up here and might have some in here, but it's hard to tell exactly what's happening. So, oh, I skipped something. So the shapefile portion of it. One thing that's really cool about this tool is all of this that we've been doing here. If you want to ingest this into something like ArcGIS, something that you already maybe have on your computer, something you're familiar with, you can take these files and very easily just import that GNDVI file, say that I created the crops mean GNDVI. We can then output that to a shapefile. So we just created a shapefile with that. And then this is ArcGIS. And then if we go to the shapefile that we just created, we add that in, we can see that all of our crops are in there, and now you can work with it in any way you want. So this could be part of your farm management strategy. You could now use this in any spatial statistics that you want to use it in that Arc gives you access to, and you can work with it just however you'd like. All of our metrics have also been passed through. So if we were to look at our attributes table, it gives you the radius of the plant, the location of the plant, as well as the max value, the mean value, the standard deviation, and the minimum value. So if you're comfortable with something like this, or you have a different GIS that you want to use this in, this is a perfect way to pass around the data, is by converting it into a shapefile and then using it that way. All right, back to my explanation of the structure. So if we look here, this is a very simplistic corn field. So you have maybe some high plants down here, some smaller plants here, but is there anything else going on? Is there any other structure? So what we do to figure this out is we go in and we look at one plant and we look at the surrounding neighbors. We compare the surrounding neighbors to that center plant, and then we also compare it to the overall mean of the image itself, or the field in this case. So your result is something like this. It says that the red areas are statistically significant lower values, the green areas are statistically significant higher values, and then the varying degrees of red and green, so lighter red, lighter green, just mean they're less significant. And then yellow means that it doesn't have any statistical significance. So if we overlay it with our original field, we can see that, yeah, indeed, these are smaller plants over here. These are taller plants over here. You have a little bit less or lower values here, and you just kind of have noise in other places. All right, so we can go back to our demo now and see how it works in practice, in kind of a real life scenario. So if you wanted to look at this field, you could do something like this, where we would take in this mean value that we just created. So this crop means, we would pass that image in. So this is the one with each one of the trees isolated. And then we could do a search distance. So we have pretty small trees. Maybe let's do a search distance of 5 meters. So we're going to look from every pixel 5 meters away and see, are you like me? Are you not like me? And is this a significant region? So we can do a quick preview. See how it looks. All right, I was right. So it looks like there is some sort of lower value in here and higher values up here. So if I was managing this farm, I might go in and say, well, I wonder what's happening here. I wonder why these plants are a little more depressed. What's going on with those? And then also what's happening up here. How can I make these look like these? We can run this on a small scale like I just showed here, or if I wanted to, I could also run it on a much larger scale. Let me open a different data set. So I'm going to navigate now to the data that's actually shipped with the crop science module. So we go to C and then program files. Oops. Harris. And then I'll go into the Ndvi folder, into the data that comes with Ndvi, and then specifically the crop science data. So all the imagery that I've been showing in this demo ship with the crop science module. So if you want to try any of this out, the data should already be there for you, and then you can come back, watch this presentation again, and follow along. So if I select my circular fields here, so this is Sentinel-2 data, and this is just some center pivot irrigation fields. And you can see that this darker regions here, these are the healthier plants. These are the ones that are currently growing. Lighter regions, maybe these weren't planted, maybe these have already been harvested, something else is going on with them. So we can isolate just these healthy regions by kind of using a couple of different Ndvi tools. So let's say, to begin with, I have, let's compute an Ndvi again. So we'll use the same example from before. So this looks at our Sentinel-2 data. It brings in all of our available indices. We have a couple more available to us here because we have a few more bands than with our last image. Our last image being an airborne image that was collected by the National Agricultural Imagery Program, or NAPE imagery, that the USDA runs, whereas this is like I said before, Sentinel-2 data. So if we bring in this Ndvi image, it's going to look something like this. It's hard to tell exactly what's happening in each one of the fields because the dynamic range of the screen has to go from those really dark values to those really bright values, and we really want to just spread that range over just our bright values. So to determine a value that can be used to separate the bright from the dark, I'm going to use the region of interest tool. All that this is going to do is help me determine that threshold value. So if I select my Normalized Difference Vegetation Index, it brings up this. So these are all the values in my image. I'm going to just look at just this top portion here, do a quick preview. All right, so it looks like I'm doing a pretty good job selecting out what I want. I can go a little bit lower. All right, let's go with something like that. So it looks like a value of 0.64. It seems kind of high. We could probably get a little lower. All right, let's call it 0.6, call it good. So if we go back into that enhanced crops tool that we had seen before, we put in this Ndvi image that we just created for our center pivot fields. We select 0.6 for our minimum value. So this is going to clip off anything below 0.6 and turn it into just kind of transparent. We'll call this, let's call it Ndvi clip. All right, we'll run that. And now if we take a look at it, oops, you can see that we've just clipped out our healthy portions of the field. And now let's go through and let's run some statistics on this. So we want to look at how these fields are comparing with one another. So do we have some that are underperforming? Do we have some that are overperforming? And if I were to be managing all of these, I want to know how one field is doing compared to another, or potentially maybe I'm looking at this scene over a large swath of land and I want to know how my field is doing compared to my neighbor's field. I know we planted about the same time. Is he doing something different than I'm doing? So let's take a look. Let's compare. So if we bring in this image that we just created, the Ndvi clip, now we'll set a little bit larger search distance because once again we've got a much larger area here. So if we say do 20 meters or even 30 meters, we could run it. and take a look. So if we just do a quick preview and see how we're doing. All right, so it looks like these fields are all doing pretty good, these nice bright green ones, whereas these yellow ones, those aren't really significant regions. There might be structure in there if you were to look at them individually, but overall, it's not really above or below the mean, it's just kind of in the middle there. And then these red fields over here, something's going on with those. There's something that could be done maybe to help solve that, but yeah, it's just there's some sort of pattern that's happening over here. The values were still high, it's still healthy vegetation, but it's just not quite as healthy as the rest of these. So that kind of shows you a way that you can compare field to field and generate some statistics based off of your image itself. All right, let's go back here. Now, all the algorithms and techniques that I've shown today are all portable to the cloud, so you can run it on the desktop just like I showed, create products, save off images, put them in a report, and be done. You can generate exactly what you need just from the desktop. However, if you start doing this at scale and you need to really start pumping through a lot of data, you're going to probably want to start looking at some sort of cloud solution. So here at Harris, we offer the Geospatial Services Framework, or GSF, and this allows you just kind of a RESTful endpoint that you can run all of these tasks and algorithms behind, and then you can just push your data right up to it, and it will process and then return the results. This is a great offering and kind of a great tool that is at your disposal in case you want to start processing, say, 1,000 images a day. Maybe you manage not only one field, but you manage hundreds of fields, and you need to know exactly what's happening on each one of those fields, and you want it as soon as your imagery is available. This is the perfect solution for that. All of the algorithms that I showed are already ready to be put up there. You don't have to change anything. You just simply put it into this framework, pass your imagery in, hit go, and then it processes it for you, and you can access it on your desktop, you can access iPad, the cloud, however you want to get to your data. So that's an option if you need to start doing stuff at kind of an enterprise level or high throughput. So that's a perfect option. All right, so just kind of a recap of what I've shown today. So the crop science module, it provides easy to use data preparation tools. That was that enhanced crops tool I showed. So once again, that can take in multi-band imagery or just true color 3 bands. You can use, once again, you can use the 3-band true color imagery to get a product that's ready to be processed with a crop counting tool, or you can select out just specific regions in an image that are ready for other imagery analysis. Also with the crop science tool, you can quickly find and count the number of crops in your field. This is great if you, say, had an insurance claim that you needed to submit. You had a huge loss. This will give you number of plants that you've lost. This will also give you, say you are down in Florida and you're having a problem with greening and you start looking at your trees, you're able to identify which ones are currently being affected. This will tell you locations of those trees, and then you can go from there how you're going to manage that. This calculates statistics about each individual crop. Once again, based off the location, your index can go from there. Perform spatial trends analysis on one of the 27 broadband greenness vegetation indices, if that's the kind of data type you're using, or if you're using hyperspectral, then you have the full breadth of indices available to you, those 51 total. It has easy to export results to a shapefile, so you can pass what you've done right into ArcGIS or any other GIS that you're using. And it provides enterprise-ready algorithms and solutions. Just like I showed, you can use GSF, use these algorithms, and import it right into the cloud. So if you have more interest in what I've shown here and you want to see a specific application of it, we have a white paper that's just been released. So this deals with sugarcane plantations and the development stages of those. This is the link down there at the bottom. If you want to get access to it, just head on over there and you can download the paper, get a little bit more information about the tool and exactly how it can be used to identify the different development stages of sugarcane. All right, and now we'll open it up to questions.
Great, thank you, Austin, for the very informative presentation. Speaking of the white paper, I am going to send out a follow-up email in the next 24 hours with a link to the recording of this webinar, as well as the PDF, of this presentation, and then the white paper link. So you're welcome to download that. At this point, we're going to answer some questions. If we probably, I mean, we're already running over, so maybe 5 minutes of questions. So if you have any questions, type them into the questions chat box in your GoToWebinar dashboard. So we got a lot of questions about imagery. So one of the first question is, have you analyzed thermo-infrared imagery? And can it be combined with hypospectral, VIS, NIR?
So yeah, it seems like this question is trying to get at maybe evapotranspiration or something along those lines. So yeah, these tools are super generic, so you can bring in any type of imagery that you have access to. So whether it be thermal, hyperspectral, or veneer like you have there. Yeah, as long as you have access to the data, you can bring it in and whatever you want to derive from it. So whether it's looking at cooling effects of, like, say, I don't even know what. So you have a drought and you're looking at how that's affecting your almond orchard. Is it getting colder? Is it getting warmer? At what point do I need to start watering? You can, yeah, if you have access to the imagery, you can derive whatever you want on the full image, and then you can go in and drill into each individual tree.
Great. And then what resolution do you support with satellite imagery?
So once again, we're kind of data agnostic. The most important thing, if you want to isolate individual crops, you have to be able to see those crops in your imagery. So for satellites, it is important to have a resolution that is high enough to identify each individual crop. So something like 2 meters, 3 meters, 4 meters is going to be some kind of on the order of a tree. If you want to get into like row crops and very small things, you're going to need probably UAV data or high resolution airborne.
And then to add on to that, is it possible to count crops with an Rgb data like a Jpeg or Geotef?
Yeah, like I said before, if you have just a 3-color or a 3-band image like Rgb, you can bring that in and you can use our enhanced crops tool where you just use the green band and invert that. Or if you find a better result using the red or blue band, you can invert those as well. And then that also helps with the thresholding as well. We had access to the near infrared band when I was doing my demo, so we were able to cut out those shadows a lot easier. However, with near infrared or with RGB, it's a little bit harder to get at those shadows. So you need to kind of play with those thresholds to isolate just the crops themselves and then pass that in to be counted.
Great. The next question, what platforms does the crop science run on?
So it can run on anything you want, Linux, Mac, and Windows. It's just like Envy. You can run it on any platform.
And is there documentation to help people like walk them through what all the crop science tools are and what they mean?
Yeah. Yep. Of course. If you purchase the crop science module, we do have documentation that comes along with it. It looks. I can actually show it to you. So under the help, crop science help, and then this is what the documentation looks like. So you have access to everything that you need. It talks about all of the APIs as well as the tasks. So that is if you wanted to run all of these programmatically, it will give you information about how to do that, as well as it gives you help on setting the parameters. And then there's also a tutorial out there as well that kind of walks you through a little bit more and can help you identify different things in your field. And yeah, so yeah, we have ample documentation.
Great. So to use crop science, you have to have Ndvi. People are asking, like, what Ndvi can they use it on? Can they use it on Ndvi 5.3, 5.4? Is it free of charge or included?
Nope. Yeah, it's Ndvi 5.4, and this is an add-on module. So there's a fee associated with it, but yeah, it's Ndvi 5.4.
Great. So I don't know if this is, so there's a question about some Sentinel-2 imageries are bright and full of color, and then others are really dark with no clear colors. Can this issue be fixed?
So I'm not quite sure exactly what this question is asking, but I'm guessing it's a just kind of a dynamic range issue. So say you load up the image and it's dark, but there might be some very, very bright clouds in there. So it's trying to separate when you view an image on the screen, you essentially have 255 different colors that you can project to the screen. The Sentinel-2 image can collect a lot more data than just 255 values. And because of that, it has to spread those colors over a wider range. And so if you have really, really bright clouds, it's saying, okay, here's my upper bound is some giant number, and then, oh, I've got also water or something that has a very low value. It has to spread that data range into just those 255 buckets. And because of that, sometimes your image will look dark in certain areas based off of this problem of having to spread it over such a large range. If you were to clip off those top values and only look at the lower end values and then spread those over the 255 range, you can get a lot better representation of what's happening with your imagery.
Perfect. This question's good. So can crop science be applied to crops like rice and wheat and not just trees?
Yeah, of course. We've run it on a whole host of things. Just recently, we looked at some corn, so it was at V2, and we were counting that and kind of looking at the health of that. We've also run it on strawberries, and we've run it on potatoes, and we've run it on dates and palm oil, and yeah, we've applied it to all sorts of different applications. And it also doesn't have to be just a small image either. Recently we ran it on a strawberry field that had over 1 million plants in it, and it ran through. It took a little bit of time, so about 90 minutes to run, but it counted over 1 million plants. And actually, kind of a peek inside yesterday, we were working on speeding that up even more. So hopefully, we can get a result out to you even faster in the coming months.
Perfect. This question's GSF related, but does GSF store data in the cloud, and is it secure?
So yes and no. So GSF, I mean, yes to everything. But so GSF is the platform. So you can deploy it anywhere you want, and I mean, you put it on your cloud, you run it, and it's an endpoint. So it's essentially running Ndvi and IDL as a hosted service. So you can get to it from a web client, but yeah, it's as secure as your network is secure, and it has as much storage as you have storage. So
all right, perfect.
Yeah.
Okay. So with that, we're going to wrap things up here since we're running over time. So if we didn't get to your question, then someone will follow up with you later. And just a reminder, we did record this webinar, so we'll send out a link, an email to everybody in the next 24 hours with a link to that, as well as some other helpful information that would help you be able to use stuff. And thank you, Austin, for the great presentation. I appreciate everyone's attention on the line, so have a great rest of the day.